I'd like to introduce Alex Ivkin. This can be a very provocative conversation about shark bait. I like that. Just a quick introduction about Alex. He's the Director of Solutions for Eclypsium in Portland, and he specializes in security solution architecture, advisory, and implementation of firmware and application security, container orchestration, and IAM. He's presented at many conferences and security events, and has co-authored the ISACA CSX Professional certification. And when he has some free time, he loves to climb mountains. So please welcome Alex.
Yep. Thank you, everybody. Thanks for coming. As if you've ever seen any Kubernetes presentations, they're always nautically themed, and that's because Kubernetes translates from Greek to pilot, or ship's pilot. So we're going to do it, but we're going to do it in a slightly different fashion. We need to be pirates, right? We're hacking Kubernetes. So we're going to go in. I got a couple of guns. Didn't find the swords, but I got the guns. My boys were a little protesting, but hey. All right. Okay. Good. So we go. All right. I'm Alex Ivkin. You heard all about this. We're based in Beaverton. Now, Kubernetes. I want to take the first step in adopting the developer mindset, because we've heard developers, and this is where it all started. So when the cloud came about, the cloud made a great promise. The cloud told developers, hey, you don't have to install your own servers. You don't have to provide your own network infrastructure. You don't have to provide your own storage. We're going to take care of it for you. And the developers said, cool, sounds great. The cloud took off. Then the containers happened. The containers said, look, we're going to package up all your dependencies for you. And in fact, we're just going to deliver this whole thing for you. And developers said, awesome, love it. And then came Kubernetes. So Kubernetes' great promise to the developers is the fact that you can package up all the dependencies, all the infrastructure, all the requirements for your application. All you need to worry about is just getting your application running. You provide what's called a declarative model. So you just tell what you want, and then Kubernetes gives you all of that. And developers said, awesome, man, we love this stuff. And so it said in the declarative model, we're going to move from this to this. And I said, cool, that looks great. That's just awesome. Everybody took on this and thought, hey, now finally we can stop worrying about this pesky IT stuff and having to configure everything and deploy it and get it all deployed the way we want. So then the reality started hitting a little bit, and they thought, okay, so I want to throw a bunch of containers on the cloud. And what do? I install the containers. All right. Well, then I need something to have first an ingress point, meaning somebody needs to come into my containers, and then containers need to talk to each other. When they're microservices, they need to really communicate, know how to find out about each other, know what APIs to expose. So I need an ingress point. And then, oh man, I'd love to monitor my containers too, because wouldn't it be nice to actually know if it's up or down and if there are any errors or logs? And they said, okay, well, we're going to introduce the metric store and the log store and a couple of systems to monitor this stuff. And then they heard about the security thing, and it's like, yeah, I just want to get them off my back, so I'm going to throw in some auth server just for fun, and then network controller, all right, well, we're going to do it. And then they finally realized, okay, so now we've got a lot of other stuff that's in Kubernetes. We need to somehow manage that too. And first of all, you need to provide a store where all those containers are coming from. So you need to supply a registry. Okay, we're going to do that. In order to install my stuff through declarative fashion or through an actual support method of package deployment, I'm going to introduce a package manager. If you're familiar with apt-get, that's essentially what it is, except it's for Kubernetes. I also need to manage my security now with TLS security, so I need something that would negotiate and procure all the certificates and install it for my containers, and then I need some storage management, and of course, I need a dashboard for all of that. So what you're looking here is what a real production level Kubernetes deployment actually looks like. It's not containers, it's actually all the stuff that's around it. And this is what we are going to be talking about in this talk. Because when you look at the actual details of the Kubernetes deployment, this is what's provided by the Kubernetes ecosystem, if you like. A lot of components that make it actually work in production are listed here. The Ingress points, I've highlighted some of the ones we're going to be looking closer into. Ingress points, the very popular one is the Istio. It provides a way of connecting into your Kubernetes cluster. The package manager, by far the most popular, is Helm and Tiller, and you'll see it in the demo. The service mesh as Envoy is the one that's most popular. The metrics collector, Prometheus, is the thing that actually collects data from most those containers and details and puts that in a dashboard, a UI called Grafana. And then you have network controllers with Flannel and Calico, and TLS Manager, Cert Manager being the one that's the most popular ones. And then you've got an image store, which by far is overtaken by Docker Registry, but they're also cloud solutions. Authorization, authentication has been having a slow pickup, but it's out there. You will hear, if you're working in this area, you'll hear about Spire and OPA more. Argghh Manager has been a while. But what it is a list of systems, a list of full-blown packages that somebody developed that the whole sole need for existence is to support the infrastructure that you're putting in Kubernetes. So first of all, how does it actually work? And you need to understand it to be able to hack it. The way that those containers or those supporting infrastructures is installed is called Sidecar containers. The Sidecar containers is essentially another container that is running in parallel to your container. You don't really have to do much except know where to put your containers on, what nodes to deploy it on. And then Istio, for example, will take care of side loading all that stuff that it needs to communicate. So nothing is in your application, which is great, but then there's a bunch of stuff parallel to your application that needs to do all this instrumentation, and that's a sidecar. Now, an interesting concept that they came up with is called the mutating webhooks. And when I first saw that, and when I heard about mutating webhooks, that picture conjured out in my mind. So it's a technology to be able to understand what you're deploying in a node so that an Istio or an Envoy can actually figure out what it needs to deploy in parallel to support the application that you're running. A lot of complex stuff. Well, and then developers looked at it and said, man, shit, that's getting really complex. And then I heard, all those cloud providers in the past did a great work for me in getting rid of that IT issue that I had. Can I have the cloud and eat it too? And the cloud provider said, yeah, absolutely. Just pay us, about $400 a month, and we'll give you Kubernetes. And this is what they did. So they came up and they started offering. And they said, OK, so Kubernetes has this concept of the control plane. And this is where you basically run everything through, where your API resides, where your database called etcd resides, where all the scheduling that does the hard solutions for what's called a bin packing problem, basically figuring out you've got this huge container, where do I put it? Because I've got a bunch of nodes and it fits on this one, but it doesn't fit with this one, but there's another pod on this node. So it solves that issue. Scheduler would help. Then they also give you a load balancer to provide all the capability for providing high throughput loads into your containers. And then they obviously give you DNS management, and they almost throw it for free. They also give you firewalls so you can protect your nodes, and obviously they give you nodes, VMs. That's what they started with, and they give you nodes pre-configured for your Kubernetes. They said, hey, Mr. Developer, we give you all of that, and we're actually going to do even better. What we're going to do for you is we're going to take the part on the right-hand side and take it and maintain and manage it all for you. You don't even have access to this. All you have is an API that we give to you. And it's a Kubernetes API. You can run all kind of calls against it using the Kubernetes itself. And then we're going to put everything else, and we'll put our awesome cloud security model on top of it. We're going to put our, provide external IPs, and we're going to have metadata. And metadata sounds really juicy if you've worked with clouds. And then all you need, Mr. Developer, is to bring this stuff in. You bring your registry with all your containers. You bring your rules for deploying and basically defining, hey, declare this solution, and then we're going to deploy it for you. And then you bring all your secrets, all your configs, et cetera, to make your solution work. And of course, you come with control tools in the dashboard. So sounds really good. Sounds attractive. This is why it took off. And it's taking off even faster and faster. The trick here, from a security standpoint, is look, I painted in 2 different colors. And you have a fairly okay cloud security model on the green, and then you have it's an okay doing security model in Kubernetes. The problem is that they 2 completely incompatible security models. So this is what we're going to look at. And first, I'm going to actually lead with this slide. So I did an analysis of different ways of deploying Kubernetes, and I'll explain it to you in specifics. And so on a Docker-D, this is a containment model that your container runs in when you run it on your personal laptop or a server. So it has an op-armor profile, it has a seccomp profiler, and it's filtering syscalls. I'm not going to go into too many details on this, but the more syscalls you filter, the better you are, essentially. 'Cause there are some dangerous syscalls that actually would allow you to abuse your kernel from a container. So Docker-D comes with really decent defaults. Now, Minikube, which is a way that you can get Kubernetes started really fast on your own personal laptop or your server, comes with horrible defaults. You can see it's all red, it's not confined, it's disabled, it's almost not filtering any syscalls. So that means you can screw up your own machine, but whatever. You know, you're a developer, you do it daily. K3s is a compromise. So K3s is what they call themselves as Kubernetes -5. And they tried to get rid of a lot of components and said, here, we're going to give you Kubernetes that's easy to install. Just give us a couple of VMs and you're going to have your own Kubernetes server. Sounds great, and it even has some op-armor installed, but it's still not filtering stuff. And what I figured out is that if you have K3s, if you don't know what you're doing, escaping containers is really, really easy. And it really literally takes one call to get, if you're inside a container and you're running as non-root, you literally just run onshare-r and you're root. That's all you need. And that's because they are not filtering the onshare syscall. So that's bad. Now, cloud providers. Now, those guys actually did a little better. GCP is obviously ahead of the pack. That Kubernetes came from GCP, so they've been studying and learning it for a long time. You see, I've labeled those three in the yellow, and that's because even though they're not filtering well, what they did is they actually hardened the nodes themselves. So the VMs that your Kubernetes comes with has really, really tight controls, and this is good. So even though Kubernetes here is kind of cyclically configured, you can't really use it because the node, the underlying VM, protects you from doing that. Good. Now, that was fun, and we're going to adopt a new mindset. And going to switch into pillage, argh. All right, so I'm going to switch into a demo. I've redacted some of the IPs to protect the innocent, but we're going to do this. So we're going to first run this and see what it shows. And it comes up with a server, East Envoy. This is my first indication. I know I'm hitting a Kubernetes cluster. Then I'm going to run, and I'll have to say, I'm lazy. I don't do a lot of stuff with curl when I have tools. And so this is this awesome tool that says which cloud. I run it. It tells me DigitalOcean, nice. I know DigitalOcean is fairly fresh. I have nothing against those guys, but we're gonna see what we can do in that cluster. So this is an important step here. I'm dropping into a container. So I had a remote shell running, and then I was able to execute it into the vulnerable application, get a code exec, and get it back to my shell. So this shell that popped up is a shell that's running inside of the cluster container. You see this weird number in the name of the host. That means it's a pod within Kubernetes. All right, who am I? And this is important too. I'm nobody really. I'm not a root. I'm running in some random container. It doesn't really explain much to me, but I can write to temp, as everybody does. And so what I do is I say, okay, I'm gonna first test if I have Tiller. Tiller is a part of Helm, which is a package installer, and Tiller runs inside of Kubernetes. Helm is on the outside connecting to Tiller. Tiller is always inside. That's how people install stuff into Kubernetes. I know there's Tiller, and this is the default name for Tiller, so I know I can do some interesting stuff with it. What I do is I just get myself a Helm client component of Tiller, and then I do this. Hey, can I run a version on Tiller? And Helm tells me, yeah, you can. This is how I know I can talk to it. And once I know I talk to it, I do, hey, can you please tell me all the applications that you have installed? And Tiller says, sure, why not? Here, have a look. And this is what I do. Look at all this stuff. So this telemetry stuff looks like what they installed in their application. And then I can look at various other components, and I can see the header is installed, which is the authentication. But I listed their stuff. So what do I do with that list? Well, the next thing that I need to do is to ask for the metadata. Hey, dear DigitalOcean, can you tell something about this node? And they say, sure. There you go. Here's the stuff for this node. Now, the thing to notice here is this. It's the bootstrap token. And I'll mention it rather briefly, but for a node to join into the Kubernetes cluster, it has to go through an authentication model. That's how Kubernetes knows that you've added a node to the cluster. And for it to do this, it shares this token. Essentially, basically says, when I'm booting, I'm providing that token. The token is exchanged for an SSL certificate, then exchanged for a different SSL certificate, and this is how the node is registered. And I can do all that myself. I know the token. I know how the node has been registered. I can basically impersonate that node at this point through the metadata. And of course, I said I'm lazy, so I'm not going to do it manually. I'm going to run this tool. Kube let me in. Awesome tool. And what I do with this tool is first, I do a bootstrap, which knows about DO metadata, grabs the token, exchanges for SSL certificates, builds the profile, and then I tell, hey, I know where I need to go to talk to the API that DigitalOcean provided, remember? And then I generate it and run it on the node. So at this point, I'm registered, I'm completely configured, and I can run kubectl, which is the way of controlling container. And I run this kubectl. I can get the secrets, but I'm not really able to get the secrets because I'm a node. I'm not actually a user within that node. And then what I do, I can run another tool. I built this chart. Chart is the way of installing stuff into Helm containers. And that chart basically says, hey, just give me everything. Just do that for me. And Tiller says, OK. So next time I run the get secrets, I get the secrets. And from that point on, I can do anything. I know the secrets of that cluster. And one of the things I'm going to run fairly fast, I'm going to use another tool called Argghh, and it allows me to list everything that's in a registry. So I get it. It's a pretty awesome tool built by Just Roselle. Run this tool, pass all the passwords and URLs and everything I need I got from the secret, and I got a list of all their containers, all the images. At that point in time, what I do is I use another tool called DockerScan, built by a couple of Spanish guys. And DockerScan has this interesting thing, image modify Trojanize. I tell it what I want to Trojanize. I tell it to inject a shell into the image. And it says, OK. I tell what IP I need to reach out. This is the shell that I'm listening on. And then it's going to create a file for me, and then after I've injected, I need to push that back into the registry. So at that point in time, that image is replaced with a malicious image that I completely Trojanized. Anytime anybody runs that image, they're going to pop a shell reconnect back to me. So essentially what I did is I not only persisted, I'm also pivoted, because anybody connecting to that registry, pulling that image from that registry, will already get my shell. So pretty good stuff. And then for the final part, I can also shut down the cluster. So, they're friend for love. I'd like to make a point that it's not very typical, but it happens. All right, I'm gonna run quickly through the last slides because I had the 5 minutes warning. Assume Docker has good defaults. Kubernetes in the France, horrible defaults. I'm not going to go into a lot of details on this slide, but you can read it later. It's basically the cert manager has validation disabled, Istio has validation, Tiller has bad defaults. One thing I didn't show to you is the fact that once you have those secrets and you have SSL through Let's Encrypt, if you know how it works, it actually, one of the ways is that it creates a record in DNS. To create a record in DNS, you need shared credentials. They're in Kubernetes. So by me popping the secrets from Kubernetes, I have access to the DNS. I can create records on the DNS. So, bad. Couple of words of advice. Helm is very challenging. It suffers from an issue of nobody validates the charts that it installs, and it can install from anywhere. Like you saw, I just downloaded my own chart, installed my own chart. The worst thing, though, is Tiller. Tiller has no reason to exist. And in fact, they are killing Tiller, finally. Next variation of Helm is coming up called tillerless, but the reality there is no reason to have a tiller on a ship, right? So if you're getting into Kubernetes, a word of advice: look for something for the next version of Helm. Registry, you saw how I own the registry. There's a thing called Notary, and it's based on, basically it's the signatures. So it's PKI signatures on your containers, so that I can't modify, even if I modify the container like I did, when you pull it, it'll fail because it's not signed properly. Now, it's based on a platform called TUF, T-U-F, but everybody who knows PKI is tough. So when I did a research on over 25,000 Docker images in Docker Hub, that's the only percentage of those that actually had the signatures enabled. So it's tough. All right, it's a nod to some people in the room. Metadata is bad, so hide your metadata. GCP actually did a decent work. If you use Google Cloud, they do hide your metadata so that while your node needs to be bootstrapped into Kubernetes, your pods that are running on that node has no business knowing any of the metadata. They should not care ever. And that's it. That's my last slide. You can read it. It's really about just trying to fail gracefully and making sure that losing a container doesn't mean losing the whole cluster. Yeah? Thank you. Yeah, you can